Okay, so here's the second tutorial on apartments for, this is apartment 2 in your handouts. So here there's 25 of A, 10 of B. So again, here we just want to watch the baseboard heat is set at 14 kilowatts. The range is set at 14 kilowatts. And here the washing machine, dryer, and hot water tank are all located inside the suite. So this 1.4 kilowatts is where we have to watch out. This will not be accounted for according to that code. So here in the additional loads, 25 for electric heat, 12 kilowatts for general lighting, 6 kilowatts for the electrical vehicle supply equipment, and 45 RPS, which is restricted parking stalls. So we carry on to our first portion here. So here again, all we're calculating for is the conductors that are required to feed the individual suites. So the first 45, 3,500, 1,500 for the second 45, and I'll just go down here. The heat, this is where you want to be aware. Here 62,118 is what's being applied, and the original setup was 14. We take 10 out of 100. The remaining 4 kilowatts at 75% gives us 13. The range, be aware here because we had our range set at 14 kilowatts, so we have to adjust that. And here the washing machine, not applicable. So we're not going to count the washing machine because when we look at this code here, subrole A is telling us that anything under 1500 watts is not accounted for. So this is 1.4 kilowatts, so that's why it's not counted. So the dryer is taken at 25%, again under subrole A, 7A, and the hot water tank is also taken at 25%. So we add it all up, we ended up with 23.5, 28.3 divided by 208 times the square root of 3, or 360, whichever one. We end up with 65 amps and 78. So this is deemed non-continuous according to 8202. And then 4-004, 14104 for our wire and breaker, we end up with a number 6 and a number 4. So we carry on. Here we have the remaining loads, and this is the part where we're starting to calculate for the main. So what we're doing is we're going to remove the baseboard heat from the suites. This is where you want to be aware again. We're removing the 13,000, the calculated value, not the original 14K when we set up the question. So we're removing the 13, the 1A4 value, and we end up with 15.3 and 13.5. So here we take the first one, our heaviest load, which is the 15.3. We take at 100%, and then the next two, we take 15.3 times 2 at 65%. We take 15.3 times 2 again at 40%. And then here, since we've used up, what to be aware of is in this portion of the question, the first 3, we're going to exhaust the first 5 units. So here we have, out of the 10, 5 are accounted for. So here we're looking at 15,300 times 5. That's the remaining 5. Plus the 13.5 times 10, because we can steal from here. So we got 25. This will be 25 minus 10. We're going to take those at 25%. Gives us 52,875. And then we have 15 unit A's remaining, so we're going to take 13,500 times 15. We're going to take those at 10%, and that'll be 2,250 for a total of 120,555. And that is going to be the first value that's going to contribute to the total watts in the end. Here we're going to reinstall the heat, so what's to be aware of here is we're going to use the original values set up in the original question. Right here, this 14K value is what we're going to use. So not the 1300 adjusted value. That's be aware of that. So we take the original 10 kilowatts, there was 25 units, gives us 250 kilowatts. Unit B, the original 14 kilowatts times 10 units, gives us 140. So we add all that up, so 250 plus 140, that's a 250 plus the 140, gives us 390 kilowatts. We're going to take, according to 62118, subrole 3A and B, 10 kilowatts at 100%, gives us 10,000 watts, plus the remaining, so 390 minus 10. So we end up taking 380 kilowatts at 75%, gives us 285,000, which leaves us with 295,000 watts. And this is 2. This is the second value contributing to the total watts in the end here. So additional loads, A202, subrule 3E, and remember this is a code test, not a calculation test, so you want to make sure you give me all of the codes as presented in the handouts with the answer keys. So the electric heat, 25 kilowatts at 75%, gives us 18,750. General lighting gives us 12 kilowatts at 75%, gives us 9. The electric vehicle supply equipment, we have instruction through A2023D, table 38, to take it at 100%, so 6,000. And our restricted parking stalls under subrule 4, 8400 subrule 4 deals with RPS. The R is restricted, so it's telling us to take 30 times 650 watts per stall. And then the remaining here, we got 15, so we're going to take those at 550 watts. We're going to multiply that at 75% for a total of 2812.5. And now we add all of this up and we end up with a total of 54,562.5. We're going to divide that by 0.7 because of our 75-degree rated connecting temperature set up in the question. We're going to take that and be aware this is 6B, 81004 6B, because this is linked to the single conductors that we'll be using. So 77,946 watts total. And that's 3, so this will be the third value contributing to the total at the end right here. So we add up 125.55, 295, 77, 946 for a total of 493, 501 watts. Then we just sort of start down the path here. A100, so we're going to times 208 times the square root of 3, or divide it by 208 times the square root of 3. We're looking at 1,370 amps, 12108, subrule 1A through F. We're going to take this amperage. Now don't forget, right here is a 1400 amp MCCB. It's important to be aware that we're going to use this value here to size our breaker. What we're doing when we parallel by 6 here is we're calculating for each conductor in the phase. So there's 6 conductors per phase. So there's 6 A phase, 6 B phase, 6 C phase, 6 neutrals, and so on. So each one of the 6 is going to be 228 amps. And then because of our 75-degree rating, we're going to apply in table DAB note 2, which tells us to take it. The D rating factor is 0.886. So we're just going to bump 228 up by 0.886 to 250 amps per parallel. And again, a little note here. So when we look at the 258 and we're going to install this 350 MCM, when we have 6 of them, when you take this and you times it by 6, you end up with 1,548 amps. So that's good for the 1400 amp overcurrent device that we're looking at here. So for 258 amps per parallel gives us 350 MCM. That'll cover it, and there'll be 6 of them per phase. So we just finished down the path here. 14104 gives us our breaker size. Now we don't have breakers of this range in table 13. It stops at 800 amps. So this will be just whatever sort of is the standard size. Leave it up to the engineers kind of thing. But somewhere around a 1400 amp overcurrent device. 10114 is telling us to use a number 6 min. When we size our overcurrent device or our bond, according to 10616, subrule 2 is dealing with services, so be aware there. Table 16 gives us a number 4/0. And here we finish off with 4-008. Subrule 3, 4, 5, and 6 deals with the sheath currents, and that's the result of using single conductor cables. And that is it. So just to recap a couple of the areas here that we're looking for that you want to be aware of. This is where I find problems from students, is the 14 kilowatts, anything over 10 kilowatts with the baseboard heat. The range, the 14 kilowatts, anything over 12 kilowatts is where I get issues. And then here, the washing machine, the 1.4 kilowatts does not count. So the students sometimes will add this value in. So when we're calculating here, you have to be aware of that we're going to apply 62,118 right in this line here, 1A4, and 8106 sub rule 3 is telling us to use the heat. So we have to take that 14 kilowatts, 10 kilowatts at 100%. The 4 kilowatts is taken at 75. We end up with 13. The range right here, because we're over 12 kilowatts, we have to take 6,000 watts for the first 12, and then following 2 kilowatts, because it's 14 kilowatts, so 12 kilowatts plus 2 kilowatts. So the 2 kilowatts extra we're taking at 40%. And that's where we get the 800 watts. And the washing machine here is not applicable. We do not, because of this rule, we do not add the 1.4 kilowatts. And make sure we take the dryer and a hot water tank at 25%. So that's where I get most of the issues in here. And also be aware that when we input 8100, that you're divided by 208 times the square root of 3. That's also a place where I get issues with students, is they forget the square root of 3, and that really gives us a much larger amperage in here. So be aware of that. Also right here where we have the 13,000 watts that comes from 1A4, that comes from right here, our 13,000. And remember, in the original setup there was 14 kilowatts here. We adjusted it in this part, and then here when we remove the heat, and again at this section, the next 3 sections with the remaining loads, the sweep calculations, and then the additional loads, that's all being, we're calculating for these service conductors. So just again, be aware of what this part of the calculation is dealing with. So be aware here, the 13,000, we want to remove this value, not the original 14. We want to add these up. Typically, I don't get too many issues in here. And then here again, the students sometimes will not reset this part of the calculation. So 10 kilowatts and then the 14 kilowatts right here. It's important that you install the 14 kilowatts because we're basically resetting with the heat. So you don't want to install the 13 kilowatts. This is where I get students will install that calculated value as opposed to the original. So, and adding them up, again, typically no issues in here. Electric heat, so the 75%. And this is where I'll get some issues in here as well, is the EPSE will, sometimes the student will just instinctively take it at 75%, and some calculation issues with the watts per stall based on the restricted or the unrestricted. Subrule 3 deals with unrestricted parking stalls, which I would express as UPS. And in this case we have restricted, so we have to apply subrule 4. Here, don't forget A104 6B. 6B is dealing with the 0.7, and again, that's linked to the single conductor cables that we're using. And that's about it. So once we add it up, again, the problem area, the square root of 3, students will forget to apply the square root of 3. Or the parallel, and and when I get the sizing of the overcurrent device, students will use the 228 amps or this 258 for the parallel conductors. So, but and if you think that through, it doesn't really make a whole lot of sense to do that because we know that we have 1370 amps that we've accounted for. So just be aware, we are not using the 258 or the 228 because that's linked to the conductors. So when we size our overcurrent device, it will be based on the 1370 or whatever we calculated this part of the calculation. And that is about it.